All right. So here we are, guys. Today we're going to be looking at 4.2, and this is going to take us a couple days. The good news is that I don't think we're going to have homework today. Pretty sure of it. And our focus in this is going to be, it's really truly sketching, but I've already committed to writing this. We're going to be graphing rational, which remember that's just the shorthand, the Q for quotient, graphing rational functions. Okay, now, two approaches that we're going to take with this. And I really don't mind which one that we take, but we're going to see both of them. So two approaches. Rational. So all this means is that we have fractions. That's it. Okay. Two approaches. The first of these approaches that we can deal with, and one of these, and I won't tell you which yet, one of them your book doesn't even include, and I don't know why, but that's okay. One of these approaches is going to use transformations, or just transforming the parent function, which is just y equals 1 over x, that reciprocal function that we saw yesterday. Now, to work this out, we're going to do one that's not terribly ugly real quick, but we're just going to do it really general to see if we can recall, because I think we've used a bunch of these letters already this year, and maybe you haven't used them at all, and it'd be a good review. So hypothetically, and this isn't a true graph one yet, but let's say we wanted to graph a over x minus h, and then all the way out here there was a plus k. And I'm going to move this down just a little bit on mine. You can just use arrows to move it, and it'll work all the same. Have we dealt with anything with h's and k's this year? Yeah. Okay. What does this value of k right here, what is this going to impact on my graph? So kind of the y-intercept stuff, but it moves my graph how? It can up, down. So vertical translations, right? Vertical shift. If it's plus 5 on the outside here, instead of the asymptote being at 0, it'd be at y equals 5. It's just been moved up 5. Okay, what did this h, just the h, represent? The horizontal shift, good. And there's only one more. And this one, remember, it's that wonky one. If it's x minus 2, it's moved 2 to the right. It's the opposite, right? It's that weird part. What about this value of a? So it's not the x-axis. This one, and this is a dumb way to do it, but like k is for vertical, is how I do it. H is for horizontal. A is for orientation. So if we have a parabola is where we spent a lot of time, this is a positive a value, and then that's a negative a. That deals with it doing what? Reflecting, but it also changes whether it's thin or wide. So orientation and shape is what this really is. I'm going to say reflection slash, and I'm going to, this is kind of cheating, but I'm going to call it steepness for lack of a better word. Okay, we have seen all these ones before. Does everybody, whether you remembered it perfectly, does this all look kind of familiar to you? Okay, so this is one way that we can graph these functions. And without saying a whole lot else, we don't need to make big tables. We're just going to jump right in and try to graph one by using these ideas. As long as we're comfortable with the parent function, 1 over x, we can try to use this to help us make sense of it. So let's look at one. And I'm just going to do an example next to it over here. So let's try to graph here using this idea. Let's do g of x is 4x over x minus 3. Now, right off the bat, is this exactly in this form yet? Almost. What's not quite the same? That x shouldn't be here, right? So here's the thing that we can do. If we want to rewrite it this way and just use these transformations, we can. What's actually happening? 4x, and we say over, that's how I just said it. So kind of, but the 4 certainly would, right? But let's go a step further. This is 4x being what by this? It's dividing, right? Did we ever do division? Just have we ever divided something by something else like this? could we do this division here? Do you want to do it long division or do you want to do it synthetically?
Long.
Interesting. I heard both options. You would do long division? Okay, so if you're more used to long division, I think we should use synthetic here just to get the practice. Plus, I think it's a little bit easier. If I want to use synthetic division, and Benj, does that ring a bell at all? Have you ever done long division with these where we take 4x divided by x minus 3? Okay, so we're going to have some backtracking to do at some point. Or you might like the other option. We'll see. Okay, checking this out. Help me divide. If we're going to do it synthetically, what is my dividend, the thing that's getting divided? 4x. Is there a constant that I'm missing? So there's no constant written. Am I missing one then? If I'm trying to do it synthetically, we'll put the 4 here for the 4x. And how many constants? 0. What goes on the outside of my synthetic box? Not negative 3. Just 3. X minus k is what we're dividing by. And Lucy, to start synthetic division, how do I kind of start it? Think of Snoop. Indeed, or lion, depending on the year we're in. How would one drop it? I don't know if you know hip hop. I don't really. Like it's hot, so this 4 just goes straight down. So my hope is that the stupid thing, just so you know, I don't really think Snoop cares about synthetic division. But any time that I get a chance to have something that might resonate, like I'm getting older and it's getting harder, but I bet I use that for the next 30 years of my career. People are going to stop knowing. Now what? Multiply. 3 times 4 gives me 12, and then I add straight down and I get 12. What did we just find? Remainder. So what we've really just found is that another way to write g of x, instead of saying it's just 4x divided by x minus 3, we could just say it's 4 plus the remainder of 12 over x minus 3. And it's odd to do this with such a small thing, but we're almost in this form here. If I just switch these places, will it look exactly the same? Like, what I mean by that is if I just write it as 12 over x minus 3 plus 4, now does it look like it's exactly in this form? A over x minus h plus k. I think so. I'm pretty sure of it. Okay. Now, from this, if we're comfortable with the parent, this, and you would never normally write this, but I want to make sure it's very clear as we're doing it now. G of x is the parent, which the parent function is just our reciprocal that we saw yesterday. We'll just say y equals 1 over x. Moved, and let's just look at how it moves. What did this x minus 3 change if I know that's horizontal? So we're going to try this a different way rather than just calling out and awkwardly waiting for somebody to volunteer. I'm going to give you guys about 60 seconds. I want you to tell me what impact does that minus 3 have on the parent function? What impact does this have? And what impact will this have? Talk with your neighbors instead of to me, and I'm going to call on a few random people. We have all this written here to hopefully help. Okay, 60 seconds. Talk it out with your neighbors. I'm going to call on a few randoms. If I'm looking at this, how is it moved? The parent function has been moved. Careful, that's a weird one. This is opposite. 3 right. Because the y right is because anytime we see these, we see x minus h. What is the value of h that we just had? It's already x minus. What is this? Yep, that's what we get the value of h. Because it's x minus when it's written. It's always the opposite. Just like it was before, it's a weird one. Okay, what does this do? So 4 up, and then what does this 12 do? 12 times steeper. And that's a weird idea. It's steeper by a factor of 12, or vertically stretched by a factor of 12 is what you could say, but I'm fine with steeper. Now, we're going to graph it right now, and we're going to make sense of this. Because, is that your question? How do we graph it? Good. Well, let's try it. Let's just see what it means. Okay, so right here, I'm going to be very clear with my x and my y axes so I don't get lost on it. I know that here is my normal parent function. And you guys don't have to draw the parent, but that blue one is the parent function. That's what it looks like. Okay, right now, what's up?
It looks like the alpha welding.
Does it really?
Yeah, if you did it all around, it's like you're on that side and that side.
So this shape is called a hyperbola, which is pretty cool. I feel bad that I don't know what the alpha welding logo looks like.
Oh, wait.
Looks like a diamond.
Oh, it does very much look like that. Follow. I'll remind me of that later. I have a request. But check it out. Here's the parent. Are there asymptotes on this graph? There's one right here, right through the y-axis, and one on the x-axis as well. Now, this vertical one, and I'm going to get rid of that for now. Instead of being here at the y-axis, it's been moved how many? In what direction?
3 to the right.
So 3 to the right. So instead of living at the y-axis, it now lives here. When you guys are drawing asymptotes, and I would recommend that you do, I would always encourage dashed lines and make sure you label it. And I know it can be tedious, but it's easy to get lost if you have a bunch of vertical and horizontals. I'm going to say, here's my asymptote at x equals 3. Instead of my asymptote being on the x-axis, it's been moved up how many? 4 up. So now it's all the way up here. And my graph is going to be ugly for a minute, but that's okay. And I'm going to do the same thing, y equals 4. I now know that, has this thing been reflected at all? Or has it just been made steeper? Was there any negative in here? So there's no negative up top, right? A is positive. It hasn't been reflected anywhere. So if I know that my normal parent function looks like this, I just imagine taking this. I've moved it over like this, and then I'm going to do one more thing. I need to make it steeper than this. And that's a weird concept, Kian. I think that you've recognized that that's a strange idea. To make it steeper, all that we're going to see is it changes more quickly in here. So instead of drawing it like that, there's my original parent function. I think that if I'm just sketching this, I just see it goes really quickly and it just changes really fast right in here. And if it does it over here, where else is it going to happen? If this is my parent, should it be in this top region up here or this bottom region down here? A or B? It looks like the parent, right? So it's just at B. So I'm going to get rid of all the parent functions because it's going to keep confusing me as I see it in here. And now we can get a pretty rough sketch of it in here. Yep, I was just helping us so we could see it, but I know that this one is also going to be pretty steep in here, so it's going to change pretty quickly, and it looks something like that. This is the graph of this function. Okay, from the parent function, all we have to do in this situation is we just divide, we get it in the right form, and then we try to make sense of the transformations. My only apprehension with this is this part right here, or what happens if we get a negative somewhere else, because it could get weird, right? Okay, this approach, just on a scale of 5 says, oh, this is so easy, I can do it. 0 says, I don't know what the hell is going on. Where would you guys put yourselves?
Wait, 0 means what?
0 is, nope, I can't do this. 5 is, I got this. You don't have to broadcast to everybody. Okay, so there's some people who aren't super comfortable with it. I don't always like to show different ways to do stuff, but I'm going to show you one more way, and then whichever one we commit as a class to preferring is the one that we'll use primarily. I know which one I primarily prefer, but I want to see what you guys think. Kian?
I was about to ask, what is this?
The 12 is in the steepness of this. So instead of being nice and rounded like this, notice how it just drops faster.
The purple one is the
The 12 only impacts how steep it changes. It's right on the orange one. And it's like, we can't really see it. The steepness is why it's a weird idea. But it did get steeper than the parent, if we look at it. This one's much more rounded, right? Yep, that's what it changed. Okay, so let's look at one more approach. So this approach is fine. It's using the transformation from the parent. Should we take a really quick brain break?
Yeah.
Okay, we are going to just check. This approach to graphing these things, not terrible, I hope. But I do want to show you another one, and then we'll just say which one we like to go with moving forward. Okay, can you tell if this is my preferred or not? I don't think I've given it away yet. So let's check it out. An alternative approach. So we're still in graphing these things. And I want you guys to make sure you pay attention because your input's going to really matter on how we go forward, just so you know. Okay, an alternative approach. Instead of using the parent function, Jade, we can instead use key features. And when we look at this, we're going to make sense of what some of these key features are. If I want to know how to draw one of these graphs, there's only a few real things that I think we need. We need to know where the asymptotes are, for sure. So we're going to make a few little comments. We're going to work out just the directions. And for any given function, we'll just say given, and we're going to write it in a specific form. Instead of that a over x minus h, we're just going to say given this thing, where we have some function in the top, we'll call it n for the numerator, and d for the denominator. If you are given a rational function, which this is a rational function because it's a fraction with these things, we can just identify the key features. So looking at these, we're just going to start right off. The vertical asymptotes, and I'll even make this easier, we'll say find asymptotes. That's step one. Find asymptotes. Okay. When we have a vertical asymptote, it came from our parent function when we tried to divide by what number? 0. What part is the denominator here, n or d of x? D, right? So we'll say find asymptotes. The vertical asymptote will always exist from the zeros of denominator. And I'm just going to say the zeros of d of x. And if you'd rather call it the denominator, that's fine. Right off the bat, and we'll look at a different one just so we can compare it, or we can graph the exact same function. I don't really mind. We find the zeros of the denominator, and that's our vertical asymptotes. Now, the one part that's kind of not as great about this version is the horizontal asymptotes. For this first one, I'm just going to tell you there's a shortcut. And it doesn't matter which one we go with, because whether we use the first version or this one to graph it, we're going to use the same shortcut for those. Okay. Once we have our asymptotes, I'm just going to scroll back up so we can see the graph, and we're going to think about what other key features. If I wanted to sketch, I'll wait till you guys are done writing here. Sorry. If I wanted to sketch this graph, I need to know the asymptotes, any other key parts of this graph that might help me make sense of it. Like, I didn't even draw it, but do you think this is an important value on this graph? And what is it? That's the 4 words that we could take. It's the x-intercept, not the roots, the zeros, or the solutions. If I want to graph this thing, that's an easy point to get typically. Follow-up question. If I want to make a fraction equal to 0, what has to be 0? If here's a fraction, x over y, which one has to be 0 if the whole fraction is 0? If the bottom is 0, it's undefined, isn't it? So it has to be the top. So if we're looking at this, we're trying to make steps. I can find my asymptotes here, and I'll show you this shortcut. But step 2 is find intercepts. And there's really 2 different types of intercepts that we can find. Intercept. Okay, and of these, just like we had 2 versions of asymptote, we can find our x-intercepts. They're simply going to be the zeros of the top part, or the zeros of, in our generalized form, n of x. So find me the value that makes the top part 0, and we have it. For the y-intercept, anywhere that we're at a y-intercept, what's the x value that we're at? Anywhere along the y-axis. And that sounds like a bigger question, but if this is an axis here, x and y, any of these points, how do we find out where my function is there at any of those? How do you find a y-intercept? It's the value of my function when x is what? So if we want the y-intercept, it's as easy as just evaluate f of 0. We just need to know what is the value when x is 0. Once we have these intercepts and we have the asymptotes, we're pretty much done, I think. So very different weather all of a sudden, but I like it. Let's try to use these ideas. And it might be kind of redundant. Can we all pretend, and maybe we don't even have to really pretend, that we didn't just graph that function? Can you ignore that other function that we graphed for just a moment? Okay, so we're going to try to graph that exact same function so we can compare apples to apples here. Because this morning I did it with 2 different functions, and one of them was harder, and that kind of skewed results. So we're going to try to graph that same function this way. And we're going to see if we can make sense of it. Do you need me to close the blind? Anybody getting shine in the eyes? Jay, do you want me to close it just a little tiny bit? Okay. So let's graph this one again, but we're going to do it completely differently. So we're going to sketch, rather, f of x equals 4x over x minus 3. Now, our other approach, we divided stuff. We're going to do it completely different, but we're going to see that we get the same graph, and we'll see which one we prefer. Well, right now I don't have to do the division. Let's find our asymptotes. Is there any values of x that make the denominator 0? And we can even show the scratch work for it. So if we're doing step 1, I just need to make x minus 3 equal 0. That's my denominator, right? What does this take me to x? So I just found the vertical asymptote at x equals 3. I set the denominator equal to 0, and it gives me the asymptote. Okay, for this next one, I'm going to give you a little bit of a hint here. We haven't seen this yet, so it's kind of me just giving it to you. Can you tell me what the biggest power of x in the numerator is, or the degree? So that's the coefficient. What's the biggest power? 1. And what's the biggest power down here? 1. So they're equal degrees, right? What's the leading coefficient up top? And the leading coefficient in the bottom? 1. And we'll summarize these. I'll just tell you right now, if we can pick out the degrees and see that they're equal here, it's just this number over this number. So my horizontal asymptote, and I'm just going to say degree trick, and we'll specify what that is. And that tells me that because they're the same, it's just the ratio of those numbers. The horizontal asymptote, HA, is just y equals 4. I have both of my asymptotes identified at this point. Okay, so let's move on to step 2. If I want this whole thing to be 0, I need to set which part equal to 0 to get the zeros. According to this, how do we find the x-intercept? The zeros of which part? The numerator n or the denominator d? Are you sure? So what's my numerator here? 4x equals 0, right? That's what it said it equal to. What does it give me my x-intercept? X equals 0. Still cool with this, or am I losing you guys? It's a different way to do the same problem because I want to see which way we want to proceed with. Maybe. What about the y-intercept? Can I find f of 0? It's 0 over negative 3. And I'll just write it out so we can see how we get it. 4 times 0 over 0 minus 3. 0 over negative 3 equals 0. I now have all this information. Now, the only little stretch that we're going to need is going to be on this very next part. With just this info, I think we can sketch it. So we'll do the same thing. I'm just going to sketch it here, and I'm just looking ahead a little bit. I see that I need to go all the way up to 3 and 4. So maybe I'll focus more like over here, and my graph will look a little bit nicer. Can I put on my scale my asymptotes, just like we did before? I think so. What's up? What points? Well, we haven't gotten any points yet. We'll get there. Now, I'm going to put my asymptotes just like we did. There's a vertical one at x equals 3, and I can't see it on mine, but it's right here. There's my vertical asymptote that I'll never touch, and I have a horizontal one at y equals 4. So there are my asymptotes, y equals 4 and x equals 3. And just so we're consistent, I will go in and make them dashed. Okay, so you ask, where are the points? Well, let's find one. Do we have any points that we can put on this, out of this information? So why 3 and 4? Are you looking here, right? But what do these represent? And what's VA? And are we ever going to actually touch the asymptote? So I can't use those as points, but can you tell me where this graph touches the x-axis? The x-intercept, I might say instead. Why 4? Either one. Where's my x-intercept? And what do we get for x? So I know that when x is 0, that's when I touch the x-axis. I think I can put this point, and it just so happens to be the y-axis as well. Okay, this last little part is where this one is maybe going to be a little bit odd, but let's check. Is there anywhere else that I found an x-intercept, or is it only that one? How many x-intercepts did we find? You say 2. It's just this, right? Is there anywhere else that's ever going to touch or cross the x-axis then? Is it ever going to touch or cross these asymptotes? So it means that when I try to draw this bottom part, it has to be stuck in here, right? So if we look at it, it must be here. It can't cross the asymptote. It must be stuck here. Now, here's the part where I like this logic, but I'm not sure if you guys will. If I want to graph the other part of it, I know it's either going to be up here or it's going to be here. How can I reason out, and I want you guys to reason out, is it going to be A or is it going to be B, and why? Convince me of that. I'm going to give you like 60 seconds. Talk out what is the other half of our graph, and then we'll come back and add it in. I'll give you just a moment. That little bit of logic saying it will never cross the x-axis again because this is the only place it happens sticks us into up here, and I know that this must be where my graph lives. For these, we see a small difference in scale. That's the only thing that's changed. Of these two methods, we can either do the division and then try to make sense of how it changes the parent, or we can just use the key features. Which of these two methods seems more natural to you?
Can you tell me how you get the horizontal?
So I can't, other than I'll show you here in just a second, no matter which one. Like that's the biggest benefit of this. I can tell it's been moved up 4. This one's not as clear, but there is a shortcut for it. Yep, so I looked at, it's a trick with the degrees. What do you guys think? The first way we did it or the second way, or does it not really matter? You like the first way, Kian likes the second way. What do you think, Deck?
I like the first one.
You like the first one? Lucy? Okay, so we will roll with the first way. I'm going to be honest, I way prefer the second way, but that's okay. 100% I prefer the second way, but we're different people, so we have different preferences. Okay, shall we take another really quick break? I can't tell if we're getting glossy or not. Okay, this class, it's not that much longer than everything else. We're going to do a round of bowling real quick. Yep, bowling. Okay, now there's no homework tonight here. The very next thing that we're going to do is continuing on. We've seen 2 of these, is we're going to give ourselves a nice way to find asymptotes. So tomorrow in class, we'll answer that question of how did I know where the horizontal asymptote was? This is where we'll start in. There is no homework tonight. If you would like to make some posters for Pep Club stuff, I think we're going to do it in the art room for the next hour. I have study hall today, so I'll be here. Do not go walk on the lake. If you're going to go see if the ice is thick, go to a river that's very shallow so that if you fall in, only your ankles get wet instead of your whole body. Cool.